Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our video lecture over section 10.5. In 10.5 we introduced three-dimensional sizes, or three-dimensional figures, excuse me, and the three-dimensional size is volume. So think of like a classroom or a bottle of water. You could fill those things up with water, or like a pool, you could fill that up with water, and that has volume. So volume is a three-dimensional size. And any three-dimensional object also has what's called a surface area, which is basically the area of the outside of that thing. So we're going to work with the two things, volume and surface area, that have to do with three-dimensional sizes, like rooms and holes, or water bottles or something like that you can fill with water. So we're going to use volume formulas to compute volumes and surface area formulas to figure out surface areas. So the volume of a rectangular solid like a box, V stands for volume, is the product of its length, width, and height. So the volume of a box-like shape is just length times width times height. So just remember that the length times width is the area of the base of the rectangle. The rectangle is the base, the floor of this rectangular solid. And if you multiply it by the height, then you get a cubic size, or a volume. And that's what they're trying to show here. That the cubic unit is like, imagine like a dice or die or something like that. And that's the size. An area is just like the size of the side of the square, and a length is just how far it is from, say, a corner to a corner. So now we're looking at a cubic unit. So notice, so we'll have that now. So remember, lengths are just the normal unit, areas are the unit squared, and volumes are going to be the unit cubed. Okay, and that's what they're showing here. So cube is just all sides are the same, so if you do side times side times side, it's side cubed. Alright, so solving a volume problem. It says you're about to begin work on a swimming pool in your yard. The first step is to have a hole dug that is 90 feet long, 60 feet wide, and 6 feet deep. You will use a truck that can carry 10 cubic yards of dirt and charges $35 per load. How much will it cost you to have all the dirt hauled away? Well, the big problem is the units don't match up. We have feet for the size of our hole, and then yards for the cubic yards for the size of the truck. So we need to make sure the units convert. So we're going to convert these feet to yards. Okay, so we have 90 feet, and we're going to divide that by 3. Okay, because in 1 yard there's 3 feet. So if you do it this way, you can see that you need to divide by 3. The feet cancel, and 90 feet is 30 yards. Similarly, 60 feet is 20 yards, and 6 feet is 2 yards, doing the same process. So now we have all the dimensions in yards: 30 yards by 20 yards by 2 yards. So then we're going to find the volume, which is just length times width times height. So 30 yards times 20 yards times 2 yards gives us 1200. Remember, this is a volume, so it's yards cubed. That doesn't mean you cube this number, it just means that this is a three-dimensional size. Now it says find the number of truckloads. So remember, the truckload can carry 10 cubic yards, and we have 1200 cubic yards. So we're going to need a lot of truckloads, if you can see that. So if we take the 1200 and divide by the 10 yards cubed, then we can figure out how many trips we're going to need to make, or truckloads. So that should give us 120 trips, or 120 truckloads, if this truck can only carry 10 cubic yards. Maybe you consider getting a bigger truck or something like that. So 120 trips, and each trip costs how much? 35 per load, my gosh. So you're going to have to do 120 trips, 35 per trip. This is going to cost you $4,200 just to get the dirt hauled away. So that's pretty expensive, but maybe you need a bigger truck that's cheaper, because that's pretty expensive. So that's a pretty good example. We did a conversion, we looked at a volume, and then we used that volume to convert it to a cost. Alright, another main shape that we're going to be finding volume of, other than just a box-like shape, is a cylinder, like the shape of a can or something like that, or a water bottle. So the volume of a cylinder, the formula is right here. It's pi r squared times h. So the pi r squared, if you remember, is the area of the circle. Remember, the circle is the base or the floor of this cylinder, and if you multiply it by the height, that gives you volume. So that's where this formula comes from, because we have a circle base and a perpendicular height. So you just multiply those to get the volume. this is a big formula that you'll probably want to have in your formula sheet. So it says, let's say it says the diameter is 20 yards and the height is 9 yards. Well, remember, radius is half the diameter. Diameter is all the way across. So if the diameter is 20 yards, then the radius is half of that, which is 10 yards. So we're going to use that in the formula for the radius. We're going to do pi times 10 yards squared. I usually don't put the unit in until the end. I don't like them putting the units in the middle of the problem. I think it's kind of bad form. But anyway, so we're going to do pi times 10 squared times 9. Multiply those together. 10 squared is 100 times 9 is 900 times pi gives us 28, approximately 2,827 yards cubed, because remember this is a volume, so it is a unit cubed. Alright, so that's the volume of this particular can or water bottle or something like that, or tube. Surface area. So for any three-dimensional object, you can find the area of the surface outside by breaking up the sides and just finding those areas and adding them all up. We have some quicker formulas if you want to use those. I'm not a big fan of these formulas. The only one that I really get attached to is the surface area formula for a cylinder, because it's a fairly complicated formula. This, I just like to, this is like a room, and I want to find the area of the floor, which is length times width. And then I have a ceiling, which is the same area. And then I have walls that are, width times height, or length times height. And we have opposite walls and ceilings and floors. That's why there's 2's in front of all these, because they match up. The surface area of a cube is, we just have 6 sides of the cube, and all the sides are s squared. So it's just 6s squared. But remember, since it's an area, it's still measured in square units, okay? Alright, so let's go to find the surface area of this rectangular solid. It says the length is 8 yards, the width is 5 yards, and the height is 3 yards. So we're going to figure out the size of each wall and floor, and then multiply those by 2 because they have a matching side or opposite side. So we'll do 2 of the length times width, so basically the 5, that's the floor. 8 times 5 is the floor and the ceiling, so we'll do 2 of those, plus 2 of the walls here, this 8 times 3, and then the other 8 times 3, and then the last one will be the 5 times 3, these 2 sides here, and 2 of those. Multiply those together, you get 80, 48, and 30, add them up, you get 158 yards squared. Remember, this is an area, so it's yards squared is the unit. Alright, that's it. We'll do more application and have a geometry project eventually over this material. So good luck, and we'll see you next time.